everyone, today I have come up with some of your doubts. Question number 1, the order of heat of hydrogenation in the following compounds is. Now, heat of hydrogenation is inversely proportional to the stability of alkene. Now we know that if energy is very less in a body, then it will have more stability. अगर कम energy है body में मतलब वो क्या ज़्यादा stable है. So if any person will have less heat of hydrogenation, it will be more stable. Okay, stability क्या होगी उनकी ज़्यादा होगी. और heat of hydrogenation number of alpha hydrogens पे भी depend करता है. More the number of alpha hydrogens, more is the hyperconjugative structures. And more is the stability. Okay, more will be the number of alpha hydrogens, more will be the hyperconjugative structures, and more will be the stability. Now here there is one more thing you need to remember. In Sedgwick rule, we have said that more substituted alkene is more stable. If the alkene is more substituted, it will be more stable. Now here you can see that in 4 and 3 you are having di-substituted. CH3, CH3 here also. Alkenes are di-substituted. Here also CH3, here also CH3. These are di-substituted. But 2 and 1 are mono-substituted. Only one methyl group. So we'll compare first between this and then this, because di-substituted alkenes are more stable as compared to monostable. So 3 and 4 are more stable as compared to 2 and 1. Now what we will see the number of alpha hydrogen. This carbon is alpha carbon. This carbon is also alpha, this is not alpha carbon. Okay, what is alpha carbon? Let me explain you. This is the methyl group, then this is the carbon-carbon double bond, and this is the hydrogen. Now, carbon-carbon double bond, this carbon attached to this carbon-carbon double bond is alpha carbon, and hydrogen attached to this carbon is alpha hydrogen. Now this carbon, this bond, when it will break, the double bond will come here, pi bond will go towards the carbon. So here it will be H plus, and here double bond C and negative charge, and this one. So this is the hyperconjugative structure. So more the number of hydrogen atoms, alpha hydrogen will be there, that same number of hyperconjugative structure will be formed, and more will be stable, because heat of hydrogenation is inversely proportional to the stability of alkene. It is also inversely proportional to the number of alpha hydrogen, or we can say the number of hyperconjugative structures which an alkene can form. Okay, more the hyperconjugative structures, more the number of alpha hydrogen, what will happen? Less will be the heat of hydrogenation. Okay, this heat of hydrogenation, we can write it's inversely proportional. It is inversely proportional to the number of alpha hydrogens. Okay, because more number of hyperconjugative structure can be formed. So here this is the carbon-carbon double bond. Here also there is carbon-carbon double bond. So this is carbon, this is an alpha carbon. Here one hydrogen, here one hydrogen. Okay, this is also an alpha carbon. Here we are having one hydrogen. Then here this is also an alpha carbon. Here we are having 3 hydrogens. 3, 2, 5 plus 1. We are having 6 alpha hydrogen. Here this is an alpha carbon. This is an alpha carbon. 3 plus 3, 6. Now here there is also this hydrogen is alpha hydrogen related to this carbon, and this hydrogen is alpha hydrogen related to this carbon. So if we consider these 2 hydrogen also, then we will get 8 alpha hydrogens here. So more number of hyperconjugative structure. Okay, even if you are not, even if you are considering only these 6 hydrogen atom, and here also 6 alpha hydrogen, then here there is a conjugation present, which is not present in structure form. So if there is more conjugation, Okay, first we'll see the conjugation. First we'll see the resonance. So in 3 we are having resonance also, we are having conjugation also, we are having hyperconjugative structures also, and more number of alpha hydrogen. That's why 3 will be very much least stable. Then compound 4 will come. Now come 2 and 1. Now let us see here. This is alpha carbon here. This is alpha carbon. This is alpha carbon. So here 2 hydrogen, here 2 hydrogen, here 2 hydrogen, here 2 hydrogen, and here 3. So total 7 alpha hydrogen is there here. Here this is alpha carbon, this is alpha carbon. So 2 hydrogen here and 1 hydrogen here. So total how many? 3 alpha hydrogen here. So again, more the number of alpha hydrogen, more the number of hyperconjugative structure, and more it will be stable. So here we will write 2 and then 1. So this is the correct order of the heat of hydrogenation. Because here more number of alpha hydrogen, more number of hyperconjugative structure, so less will be the heat of hydrogenation. Okay, that's why 2 will be having energy less as compared to 1. That's why this will be the correct order of heat of hydrogenation. So the correct option will be option 2. I hope this has answered your question. Thank you.